Hello friends, so here is another question on electric charge and Coulomb's law. So the question is, two equal conducting spheres of negligible size are charged with 16 into 10 to the power minus 14 coulombs and minus 6.4 into 10 to the power minus 14 coulombs respectively, and they are placed 0.2 meter apart, and then after that they are moved to a distance of 0.50 meter apart. So the first bit of the question is to compare the forces between these two spheres in those two positions. Basically we have to calculate the ratio, and in the second bit it is given that these two spheres are connected by a thin wire, and what force they exert after they are connected by a 3 wire. So there is a concept of transfer of charge until they come in equilibrium, so we will come to that. Okay, so let us solve it step by step. So first is the given data. So here given data, let's say we have two charges, okay, two spheres A and B. It has charge of 16 into 10 to the power minus 14 coulomb. This has minus 6.4 into 10 to the power minus 14 coulomb. The separation distance initially is 0.2 meter. Then the separation distance is increased to 0.5 meter. We have to compare the force between these two charges in these two positions. So this is QA, this is QB. In this case, let's say this separation distance is R1, this separation distance is R2. Okay, so in the first case, let the force be equal to F1, that is equal to 1 by 4 pi epsilon 0 QA QB by R1 square. This, okay, in this case. In the second case, where the separation distance is 0.5 meter, the force is equal to the force of attraction here, because they are unlike. Okay, see, because one is positive, other is negative, so it will be attractive force. The electrostatic force of attraction is 1 by 4 pi epsilon 0, same two charges, magnitude is not changed, only the separation distance, that is equal to R2 square. So now if we take the ratio of these two forces, F1 by F2, it becomes 1 by 4 pi epsilon 0 QA QB by R1 square by 1 by 4 pi epsilon 0 QA QB by R2 square. So here everything else will get cancelled out from both the numerator and denominator, and this will become R2 square by R1 square. Sorry. So here, yes, R2 square by R1 square. Okay, F1 by F2 is equal to R2 square by R1 square. Why? Because the electrostatic force of repulsion is inversely proportional to the square of the distance between the two charges. So here R2 square is 0.5 square, R1 square is 0.2 square, yes, 0.2 meter, yes, 0.2 square. So that is coming around, it is coming around 6.25. So the ratio of the two forces at the two positions, first at 0.2 meter and then at 0.5 meter, is equal to 6.25. Okay, this is the first part of the question. The second part is the two spheres are connected by a thin wire. So what happens is that when the two spheres having different charges, different charge values, they are connected by a thin wire. Okay, when they are connected by a thin wire, charge transfer happens. Okay, in one case it is 16 into 10 to the power minus 14, here it is minus 6.4 into 10 to the power minus 14. So now the total charge between A and B, when they are combined together, it becomes 16 into 10 to the power minus 14 Coulomb plus minus 6.4 into 10 to the power minus 14 Coulomb. This is the total charge when they are connected by a thin wire, when they are connected, and that total charge is equal to how much? Plus 9.6 into 10 to the power minus 14 Coulomb. Now it has been given that these two spheres are identical. Okay, I missed that part. These two spheres are identical in nature. Okay, they are identical in nature. So as they are identical, these charges, they will be divided equally. So the charge on each sphere A and B after they are connected by the thin wire is equal to Q by 2. Okay, Q by 2, which is equal to 4.8 into 10 to the power minus 14 Coulomb. Okay, plus 4.8 into 10 to the power minus 14 Coulomb. Why? Because charge which are identical in nature, charges between them, it is shared equally when they are connected. So now they have been moved to a distance of 0.5 meter. So now the question, the diagram will be like this: charge A 0.5 meter, charge B. Charge on each is this much, 4.8 into 10 to the power minus 14 Coulomb. Here also 4.8 into 10 to the power minus 14 Coulomb. So now the force will be by 4 pi epsilon 0, 4.8 into 10 to the power minus 14 whole square, because they are equal. QA QB will be this one, be square of this much, divided by 0.5 whole square. So we know 1 by 4 pi epsilon 0, you can simply substitute it as 9 into 10 to the power 9. So this will be equal to 9 into 10 to the power 9 into 4.8 into 10 to the power minus 14 whole square by 0.5 whole square. The result will be 8.29 into 10 to the power minus 17 Newton. Okay, so this is a very important concept here. When the two charges are connected, this concept comes into play, the concept of total charge, the total charge which is connected, the sum of the two individual charges. Then these two spheres, they are identical in nature, these equal identical conducting spheres, As a result of this, the charge is equally shared, equally divided. That is equal to this, Q by 2. Then many students, they make the mistake that in the final part, they put value of the separation distance as 0.2. See, it has been already clearly mentioned that they are moved to a distance of 0.5 meter. Then after that they are connected by a thin wire. So if we put this value 0.2 meter, then it will be wrong. Okay, always read the question very carefully and always attempt the question in that sequence, in the sequence of which the information is provided, the data is provided in the question. It has been, finally it is given at last that they are moved to a distance of 0.5 meter. So now the separation distance is 0.5 meter. After being moved to a distance of 0.5 meter, these spheres are connected by a thin wire. Okay, so this is the whole concept.